we'd like to begin, and I'm going to try not to trip on these wires. I'm actually not even going to use the lighting desk until the second half after coffee, when we're going to talk about the control of LED lights and how complicated it is to change colors and stuff. But this session, and I've already introduced myself to everybody, my name is Robert Bell with Pathway Connectivity. And if you were at breakfast, you heard that, and you probably already know that we are just a couple blocks away from here. So, and Dave, who owns the company, is right over there. And Robert, back there, running the camera. And Van Rommel, who is our international vertical development sales guru, product champion. But he's an American, so he's lucky that he's not in the room, because this is a very patriotic event.
And whose idea was this?
It was your idea, man.
And what did I tell you to do? Wave the flag.
Yeah. And yes, very good, very good. And this is Gary Douglas, who can introduce himself.
My name is Gary Douglas. I am the lead software developer for the Cognito console and a couple other consoles that will remain nameless. I am originally from Edmonton and lived in Calgary for a while, but right now I live in Atlanta, Georgia.
But you're about to.
But I'm about to come back, because Canada's just a great place to live.
Back to Charlie. Oh. Gary worked with Pathway after you worked with Four-Star.
Monty's lighting by Monty. And I worked for Pathway, and then I jumped around a little bit, and now I'm back with Pathway. Then
one of the nice things about working with a team of people who are actually interested in lighting is that Gary and I have spent a lot of time climbing trucks, and I always say the guys with the wrench in their back pocket, right? So although we do software now, like we actually really know what it's like to get dirty and stuff, and that comes into discussions all the time. But to point out what Van said, which is, this is a Canadian thing, I didn't even really think about it, but Dave was just mentioning that Cognito is probably the first real lighting control product that's been built in this country since the 60s. Pathway Connectivity, of course, has been a networking company. I always said they're like the guys that are in the closet, right? So you buy the gear, you put it in the racks, you configure it, you get it going, and it's always worked. And this is our first effort to get them out of the closet and put it in front of the customer's hands. So although Gary and I have done this before, this is really the first product that Pathway's done, which is a user product. Like somebody who has a job in a lighting theater for 8 hours a day will sit behind this product. And what does that mean? And it's a very different thing than a technician who, crimps RJ45s for a living and puts stuff in a rack. So again, this sort of brings into how we design products and how we think about user interfaces and stuff. So I did this whole presentation, and then I gave it to the guys at the factory yesterday, and I got the first slide wrong. And this is now the first slide, and this was Gabe's idea. Okay. Not to harp on the word idea, but when you decide to make a product, you actually have to have like some thought that you're going to do something better than anybody else has ever done. You're going to solve a problem. You're not just building a product hoping that somebody's going to buy it. It's like, what are you going to do to make this product solve that guy's problem? And every lighting console that is done out, they kind of have a good colleague of mine, Anne Valentino from ETC, and she used to be a very light. She built the Virtuoso console, and then, well, the Obsession first, we did Virtuoso, and now the EOS and stuff. She always says that a product has to have a DNA. What is the thing that makes it special and unique from every other desk? What is it that you're going to solve? What is the niche? So every console has an idea. We talked about the Virtuoso, which is the Artisan predecessor from Very Light. And what their thing was is, it's our console, and it's our lights, and it's our service, and that's why we're building it, because then we block out everybody else. And Van was huge at Very Light during that time too. So he knows from where I speak. If you don't remember the world of Very Light, where it was very sort of elitist and you were in a room. But that's
you couldn't buy the lights, you had to lease them. You basically borrowed them for a while for a very large sum of money, and then gave them back again.
So those were sort of legal reasons and business development reasons. They needed a console to run their lights, and they had to make sure that nobody else could run their lights. The obsession that I mentioned earlier was an absolute blatant ripoff of the Strand light palette from the 70s. And the reason that ETC came into the market and did that, and the way they designed it, is they just took the light palette manual, I know this for a fact, and said, do it like that, and don't change anything. Because that's a great console, and Strand's not going to make it anymore.
So the problem they were trying to solve was fill the hole that Strand's going to leave when they depart the market.
And then there's other ideas for doing it. The guy who hired me back in 2000, his name is Gordon Perlman. He was famous for two things. He was the first guy to ever put a digital desk on Broadway for Chorus Line, which is a well-known story if you've ever read about lighting control in our world. And he's also the guy who wrote out what DMX was going to be. And it was presented at a US CITT conference. So he's actually the guy who first wrote down what the DMX spec was. So he has a lot of history in the industry, and he's done many desks for Strand and for Morpheus and for Kliegel. And the one I'm going to speak about is the GAM Access. And that was a desk about this form factor, and they sold it for over $1,000, and it was $70 in parts.
They made money hand over fist. And they sold a lot.
And the whole idea of that console was, this is a simple desk that lots and lots of little theaters need. We'll let Strand, and we'll let ETC was around at the time, but Kliegel and those guys build these monster, at that time, $60,000, $100,000 desks to go into places like the Jubilee or whatever it was. And he says, I'm going to do all the little high schools and churches and markets and all the rest of it. So everybody, you have to have an idea, a concept of why you're going to do it. So, a very good friend of mine is Richard Pilbrow, who literally wrote the textbook on lighting, stage lighting is what it was called. And then he rewrote it again in another release, and he's written lots of stuff. But back in 1994, I was working with a company in Toronto called Cast Lighting, and Richard did some sort of symposium at it was an LDI. And he was getting myself and Kenny Rickright from Wybron and Fred Foster from ETC saying, you got cool technology, you got cool technology, you got cool technology. Can we not just stick them all together and make a product that does everything for you? So this was his idea of what a lighting control desk should look like there. And he just drew this. It's not at all software, it's just drawn. And he said, I need to see the lighting plot, so I need to know where the lights are. I want to be able to grab lights with similar purposes and throw them on a wheel, and other lights with more similar purposes and put them on a wheel. And this is a dream that he realized in the 60s when he built the original
Cat.
No, it was before the Galaxy. It was called the
Light board.
Light board. And one of the elements that they had on the light board was a little designer's remote that literally had a cable on it, and he could sit, and it was just this bank of wheels. And his idea is he wanted to paint with light, and that was his term that he did it. And they called that board the light palette. And later, when another Canadian, Wally Russell, built the light palette, they actually called Richard and said, can we steal the name? He said, oh, very happy to. But the idea here is it has conventional sort of control, this painting control, the visualization of where the lights are, standard thing, and then this was Richard's best version of what I was doing at the time, which is a product called WYSIWYG, which you could actually see the lights moving, and this is what we did together. So this was Richard's sort of dream idea of a desk that would do everything. So that was his idea. And the point of this is Richard, he's a theater consultant, and he's an incredible theater lighting designer, and an amazing politician. But he's not a software guy. And but he was like the the main guy who built the light board. And so he consulted for Strand. And then, similar stories, throwing names on the ground here. You know, Ken Billington was probably the main consultant when they built the Obsession. And everybody sort of has a product champion that will actually take this to market, and it's normally not an engineer. It's normally somebody like yourself that actually just, you know, has an idea and then needs it to go. I'll let you do this one.
Perfect. So, so this slide shows that it takes more than just the two of us to build a console. We have quite a very large team, starting with the product manager, and Robert, who is our product manager, has the vision. He is the sort of gatekeeper for all the concepts and for gluing everything together in the end and sort of sticking up for the customer in adding features and even just the layout. You know, there's definitely a purpose to the way all this stuff has gone together, and that kind of falls on Robert. But behind Robert is software architect, which is myself and another gentleman who's no longer with the company. And we have other software engineers who kind of help out with the software nuts and bolts. Then we have people who did the underlying operating system. This happens to run on Linux. Some consoles run on Windows. Some consoles run on VxWorks. There's just OSs. You know, I could give you probably 30 different operating systems that like consoles today run on. And there's always somebody sitting in a dark room somewhere making sure that all those little bits and pieces get put together properly. Now, beyond that, we have sort of real, you know, true engineers, the people who can take, you know, data sheets and little chips and bits and pieces and fit them all together on a circuit board like that and make it do something sensible. You know, it takes a fair amount of work to get this kind of thing to actually function as a lighting console. And then there's mechanical engineers who make sure that, you know, when you go to put the screws in the factory, they're actually going to fit and nothing's going to bind and the faders actually work properly and, you know, things spin and you name it. And all the way down to, you know, people in the factory. We have, you know, a small army of people here in Calgary that screw this stuff together every day and make sure that it works when it leaves. And then, you know, people who do EMC testing. You know, you can't send things out without knowing if they're going to interfere with TVs and radios or, you know, blow things up on the power grid. So we have to go through and have people that are skilled at doing these things.
Did anybody ever run a hog tube? And you ever open up a Motorola radio close to it?
I never did that.
Yeah.
It could crash it. And it will make the screen do all kinds of crazy things.
Any phone, actually.
Pardon me?
A lot of the different phones will do it.
Yeah. And you hear it all the time when somebody's phone's about to ring on a clear call. That ding, 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 just before the phone rings. You know, and so the EMC is both directions. It's like, does your product harm the environment? And will your product stand up when it's in a harmful environment?
So over the you know, number of years that it takes to do this, we clearly had a ton of people from, you know, the people that have to pay for it, Dave and you know, the people that handle the money, graphic designers for things like, you know, collateral, product brochures, and that sort of thing. You know, this stuff doesn't just materialize out of thin air. You have to have people to you know, make it all happen. So we didn't start from scratch necessarily. You know, we started from a place where Robert and Alan Martello, who owned Horizon Control, they had a product in the can that they were selling for years and years and years. And
that guy right there was selling it.
Yeah.
And Roscoe, Canada. Sorry. He was the face of Horizon in Canada.
And over the years, the industry changed. You know, right now we're changing to LEDs, but before that, we changed to moving lights. We changed to all this automated stuff. Everything went from proprietary protocols to DMX, and you could DMX control just about anything. And at some point, this Horizon, you know, all of these predecessor products, they kind of start to exceed their useful life. And when it comes to trying to fill the hole or trying to create that new vision for what control is going to be, we came to a choice. Do we want to just take this exact thing, slap a new UI over top of it, and call it a day? Or do we actually go erase it all and start at the whiteboard and start again? And I think we managed to do a little bit of both, and making that decision wasn't sort of a two-day thing. It kind of happened over, I think this was 1998, what you're seeing here.
Well, no, I didn't start with Horizon to 2000.
Okay.
But I was hired by Gordon Perlman, the guy who did the chorus line. And he's not a dinosaur, but he knew that he just didn't get moving lights. And I came from a place where I was very, very familiar with moving lights. And this desk ran conventional fixtures up and down very, very well. But they just said, well, if we just tag on some other things, it's just panning and tilting, they're just levels. It's, we can do this, right? And they sort of did, but they realized that they didn't really put the spit and polish on it. So they hired me for, it was supposed to be a 6-month contract, and I'm still here. And they said, we don't understand pallets, like a downstage center. What does that mean? How do you reference it? How do you do it? And stuff. So we carried on with Horizon for a little bit, because the new product doesn't come out of the door like that. But this was supposed to be our reinvention of Horizon to really do moving lights proper. This product was called Horizon ICE, ICE, Integrated Control Environment. It never made it to market.
Probably, yeah, nobody ever saw it. It looks a lot like Horizon, but it's fundamentally different.
Yeah, but you never sold it. So that was the question. That was the point we were trying to make. It's kind of like before you decide to wipe the slate clean, it's like what can you possibly salvage or evolve? And software goes about 10 years before you realize throw it out, start again, because you learn so much about the architecture. You learn you're just not doing things right, and that's our natural language controlling is a great example of that.
Yeah.
And that was one of the very first things I said, is you can't keep controlling these new modern lights by just fading an 8-bit value from 0 to 255. You just can't do it. You have to think way beyond the channel. So you can't even call it a channel anymore. You have to call it a fixture. You have to think about what comes out of the light. And that's a whole nother day we could talk about this thing we have called natural language control, which talks about the way to control lights in a very different way. Hi, come on in, find a chair, please.
And unfortunately, the evolution from Horizon ICE to natural language control isn't necessarily a straight line, and it isn't a simple problem to solve. It wasn't just the case of, oh, well, let's graft on something that looks like natural language control, but really in the end, it's just sort of doing DMX. You either have to jump in all the way, or you just haven't done it right, and you're going to fail. So at the end of the day, we started it. Sorry.
But before we did that, I think we'll do it itself.
Yeah.
I said to them, they had a software-only product in Horizon, and I said, you can't pan and tilt a light with the mouse. And I was big on this. But the mouse, remember, when Apple first, or Xerox really first did it, but then it was the Apple that really invented the mouse. It was just an amazing way to get, your manipulation into the screen. It was just better than a command line at any point. But to do it, you had to be looking at the screen. I mean, you ever try to operate a mouse not looking at the screen, you can't really do much. If your eyes are on the screen, your eyes aren't on the stage, which means you're really not creating the radar.
And there's definitely a psychological barrier to operating lights without having your hands on something physical. It really doesn't feel right to most operators. There's something wrong.
It's kind of like, digging a hole with a backbone.
Yeah.
You wouldn't do it with a mouse. I mean, nowadays they are mining that way, but they
flying planes and things like that, but there's still something fundamentally strange about it. So it's really hard to not have the handles and the faders and the buttons and the flashing LEDs that we're all accustomed to. It's hard to convince the market to go that way.
So I said to Gordon, we need to build a wing that will just hook up to the serial port on the computer, and I need to be able to do this. And he said, yeah, just design one, we'll build it. And I, over 18 months, designed many. None of them ever got built. What we ended up doing is I ended up going to the West End and I did a Lloyd Webber musical called Starlight Express. And we did it on Horizon. but I took in X keys, which is like a little USB mini thing that's used for Pro Tools and stuff like that.
Cash registers.
Yeah, and we're I did that with 3 of those things because it gave me 3 wheels, and I could do red, green, and blue, or I could do pan and tilt, or I could do shuttles. But it was a complete bodge. It wasn't a product. So then I said to them, I think we should build a. And then I said, to get customer acceptance, because this thing is just software. Nobody buys just software. Nobody, you can download software for free. It's just zeros and ones, right? So nobody has inherent value in the software. So I said, if we build these wings, and we want to make a real console to go in a venue the size of this, and prove to people that our software is actually really quite good, although it kind of looks like a toy because it runs on Windows. And at the time there was like the Strand Desk, and everybody else was just character-based, and we kind of looked industrial and real, and this Windows thing was new. I said you need to assemble these things into a case. So I drew this up, which never got built. Thankfully, it was just
It's hard to get people to accept a bunch of stuff glued together into a really ugly box.
But I drew that in AutoCAD, and it was probably one of the first, product-y type things I tried to draw in 3D. So this is a guy who has the passion trying to sell the idea, not to the customer, but to the finance guys. So they knew that if we ever did build this, it wouldn't look like this. It would be, a real industrial designer, a real mechanical engineer would do it. But I'm saying, look, this is the concept. Take a bunch of wings, stick them in a rack, plug them together into a computer, and you got a console. Or I said, let's just build a real one. And this doesn't look that much different than that. But I drew that in 2001. And here we are in 2013 with a product that is pretty much in the same form factor. So sometimes the battle, to convince the money guys that you need to do this takes that long. Not always.
It takes a few money guys.
Yeah.
You gotta get through a few to get the one that will eventually go for it.
So then you have great grand schemes. And this would be what Richard Pilgrim would want. And this would be the sort of thing that you would see in big theaters. But this was a design we did earlier, and again, this was exactly like Richard's picture, where you take a bunch of lights and drop them on, and then you can paint with light. And this had great ideas, because these guys here would load up these things based on position. So if you hit the position button, this would say, oh, those are the lights on the girl, those are the lights on the boy, these are the lights on the site, and these are the down lights. And you could say, oh, the girl's too hot, bring up the psych of it. And then you would hit the button and say, sort these by color. And say, these are all the ones that are in red, these are all the ones that are in blue, these are all the ones that are in amber. Oh, the blue stuff's way too hot, bring up the amber. And then you would hit another button and say, sort it based on how long they've been tracking, or did they just come up, or did they just go down in value, or did they have a go going, whatever it is. And then over on this side, and again, you see this big line here, it's because all this was modular too. So you could then sort of build up the desks that you wanted. This wasn't drawn properly because it wouldn't have had that many buttons, but the circuit board underneath could accept that number of buttons. So as you are getting closer and closer to the final product, you're saying, okay, we're just going to populate 80% of these, and this is where the gaps will be. So that's sort of how that idea comes about. And the most important aspect of this was here, and we'll steal the term that we used, it was the cockpit design, which was sort of hands-on and heads-up. And almost every desk I know, when they talk about these moving light encoder wheels thingies, always did it almost like an afterthought. And it's a shame I don't have a picture of a marquee console, which we built. But that one, when we were sent to go build the entertainment technology marquee, they said, build a slider desk that runs conventionals. And I said, you're off your tree. You got to build one that will run moving lights. And they said, no, we don't want to. That's not the market we're in. So I just laid the circuit board out. I didn't literally lay the circuit board out, but because we had electrical engineers that did that. But when we laid it out, it had all the sliders that do all the things, but then I put 4 holes, which we could then populate with wheels later, when they would allow me to build that one.
But he couldn't put them where he really wanted to put them. He had to put them up in the corner that wasn't being used.
So then that company went and bought Verily. And they said, holy Christ, we need a console with a run moving lights. And I said, hey, I got one for you. Let's just put these wheels in and you're ready to go. But the point of that deal is the wheels are always sort of out of reach. So you're reaching over the keys that you use the most to get to them, or to get close to the displays. And then there was...
They're fundamental to controlling moving lights. You can't control moving lights with a mouse or buttons. It's onerous. You really want to tweak it. And so when you're reaching over stuff, you're going to hit other buttons. And
so then there was, the other examples I use is the guys who did the Verilight desk were all Mac heads. And at the time, I hated Mac. But anybody who used a Macintosh back in the late 80s and early 90s was left-handed. Like almost anybody who owned a Mac was left-handed because they were right-brained. So the Virtuoso and the Artisan had all the encoder wheels over here. So you're looking at the stage like this, you're typing here, and then you go to moving lights. So you're like, okay, I'm typing, oh, and now I gotta move a light.
but even just the vertical line encoders is very awkward.
Yeah.
Horizontally, it makes more sense, but vertically, you can't. That is a very strange position to have your body in. So
The guy, a good friend of ours who designed the 500 for Strand, that just died in your theater.
Yeah.
He was a pure, hard-edged, left-brain thinking engineer, and it was all DOS and character-based. His wheels were over here, in a straight line. Right? Most other desks, like the EOS and all that, the Grandma and the Hog, they're up here, where you're in the main. So this was a fundamental idea, which is like, I'm typing, I'm squared at the stage, I got my hands in a resting position, and then I just do this.
There's a very.
I can still see the screen.
If you look closely at the design, there are no buttons in a vertical line down from the encoders, and that is a very conscious decision. It may not be obvious, but so you don't put your elbows on anything as you're tweaking stuff on stage.
So that was probably the best thing that came out of this cockpit design. This desk never got built. But in the process, you can't just do it all on a computer virtually. So what you do is you draw it in 2D, you take it to a big plotter, you print it out, you do arts and crafts, and you cut it out.
And normally that happens in hotel rooms in Las Vegas, or
Because we all get together.
That's about the only time we all see each other.
There's lots of pizza.
Lots of pizza and lots of trips to Staples.
And that was an interesting thing about the team, and going back. The guys who put this desk together, I don't think a single one of us lived in the same city.
Nope. Or 11 of us, and none of us were in the same city.
Calgary, Toronto-ish,
Bournemouth, England.
Pittsburgh,
Bournemouth, yeah.
Bournemouth, England, Orlando, Dallas, Van was in Atlanta, and
Calgary?
Calgary.
Or,
Oh, Connecticut.
Connecticut. Yeah. And Fort Worth, Texas, or where?
Dallas.
Dallas.
Yeah.
Yeah.
That was pretty neat, that we can do all of this with Skype and Google Documents and all the rest of it. And we have code that's checked into virtual machines like that. But that's not the point. The point is these phone core things is, hey, we're all going to be at LDI. Let's go up to Rob's room. We'll do arts and crafts. We'll build this thing, and we'll actually say, hey, do we need to move? Maybe we'll just move the wheels out of it. No, we'll put it. And then it gets into a religious debate. But this is the our equivalent of a maquette. And it's funny because a director looks at a maquette and they go, yeah, that's great. And then they always get on stage and say, I didn't know it would look like that.
I think about the only thing we didn't have was a feng shui consultant.
I remember moving the furniture around in the hotel room before we started the arts and crafts. So then you have to start thinking about the the guts. And this is where the software architect that was on the first earlier slide comes into it. Now we have some guys that write software, and they're pretty good if you give them you may have heard this from school, pseudocode. So basically it's an English version of an algorithm. So it's kind of like, okay, well, you get up in the morning, you put your pants on, you know, you go brush your teeth, you get in the car, and you drive to work. That would be pseudocode for a routine that you do. And you can give that to a software developer who hasn't climbed ladders with a wrench in his back pocket. Because if you lay it out clever enough, detailed enough, they can write it in C++ or Java or Basic or whatever it happens to be. But we're at the very early days, and this is when you're not just reskinning a product, but you're starting again from new. You actually have to do the software architecture. So the really, really big thing that we did here was this idea of natural language control. And that was mostly done in a white paper I wrote, which has been going around for ages now, called the abstract control model. And that was that idea of you're not going to control these lights by fading a value from 0 to 4. You have to think about what comes out in front of the light and what happens when it hits the stage. And these are the things that you will fade. And there'll be an example of that after coffee when we talk about color spaces. And we'll actually show it working here.
And it's really about hiding all of the geeky bits from the user and making it natural, like it's called. We make sure that you never have to read a manual for a fixture. You just, if you want it to go to pan 90 degrees, it goes to pan 90 degrees. And so our job as software people is to take away all of the hard stuff and make it look easy. So we have to go in and you know, understand what 90 degrees means to the DMX and hide that from you. And if you see it, that means we've not done our job.
So you do an awful lot of drawings like this. Yeah. So it's kind of like, okay, well, here are your inputs. This is the fade engine, and it has things like scheduling and and then all of that goes to outputs. So there's, you know, DMX lines or different protocols and all the rest of it. And again, these are useful aids when you're, you know, trying to justify your job, you know, to other people. But it also helps, you know, to communicate some of the thoughts between the really geeky people, and it turns into pseudocode, which then turns into code, which then turns into bugs. Which eventually will turn into a shipping product after an alpha and a beta cycle and
and 800 revisions of software.
Like, how many lines of code do we now have in this?
It's at least 500,000, at least. It could be a lot more. If you count the bits underneath the firmware, it's at least 1 million.
Yeah. And that's not a good metric, but it kind of gives you one. I'm thinking, wow. So like these guys did it, you know, last weekend.
And the interesting thing about this slide is that it proves that a lighting console, or shows that a lighting console isn't just one little piece of software that happens. I mean, in the case of Horizon, it kind of was. But when you get into doing the actual hardware and all the other bits, focus remotes, and things that go along with it, the project kind of mushrooms into 10 or 12 different software and hardware projects that all have to appear as though they're one thing. So just about, you know, in Grandma, the EOS stuff, there's at least 5, 8 pieces of software running on any of those platforms. And so it's quite a daunting task to draw that block diagram and see, or at least try to understand what you have to do to bring it all together into a cohesive piece.
This circuit board alone, which is in here, has 4 processors on it. There's one that just blinks the power button when everything else is turned off. And we actually just reprogrammed
Just
it.
fixed it.
Yesterday.
Or changed it. We didn't fix it.
There's 2 satellite ones, one that deal with the DMX. There's another one that deals with all the other ports and essentially doing some other stuff. And then the main one that runs all the software. So those things are all written in different languages. And then they need to talk to each other on these things called buses. You know, so there's a protocol that you actually have to, you know, 2 software guys, this guy in Bournemouth, Philip, who did the satellite processors, we call them, and Gary's responsible for the main code that goes on the ARM9 that is actually running the main code. And there's an awful lot of communication that happens back and forth between them. Never mind the iOS stuff,
Eric
which is
stuff.
just,
Which used to be 4 programs, now it's 1.
yeah, you know, and trying to get it to talk over the wireless. Whole other headache. So then, when you start doing it after the foam core and stuff, you then build a mimic. So this is a little application that I wrote, which I could play with, and I could talk to the main engine. So while Alan was building the main fade engine that would actually take a light from 0 to full, you needed some sort of input to say, okay, you know, 1 through 10 at full. So I would use this, and I would, in my best pretend thought with a mouse, pretend that I was actually touching. Okay, 1 through 10 at full. Wow, that through is a long reach. Maybe we should put the through over here, you know. And well, how do these soft keys work when I hit the shift button or the go button? And, you know, so this really helped us get to where the button layout is and what are the real buttons we need. And out of this will also come the syntax of the desk. So I remember, I think it was the marquee, the original marquee desk. I presented the final version of the key layout, and it was Gordon and some other executives. They said, "There's not enough buttons on there." And I'm like, "There's exactly the right number of buttons on there." Like, I didn't just throw them down. I have the whole syntax worked out. I know how the desk will operate with the buttons that are on there. And they still weren't pleased. So that's where I showed you we actually populated other areas where you could actually fill them up in case, you know, the product changes down the
It's
road.
easy to print extra pads on the boards and just hide them later,
Yeah.
just to satisfy you.
But you have to think at this stage exactly what are the buttons we need. Do we need an update button, or can we override the record button? So you hit shift and record and it does update. And that's what we very specifically did on this desk, because you can guess these are, you know, 20 faders with 20 bump buttons. There's a go button here, there's another go button here. This is a Grandmaster, and this is a Memory Master that does this. And really, the only buttons, forget about the ones above the wheels because they're associated with the wheels, are 4 here and 4 here. And that was a very conscious thought, because this desk is going to be sold to people who don't sit behind it 8 hours a day. Like when we were doing the light palette and the bigger desks, you know, it was okay because you could, you know, train a guy on the desk. You could spend 3 days training him, and then that's what he does. Like somebody who, you know, I don't know, does other things.
And you can do a lot with a 10 key and a command line. So there's a lot. You know, that center section of buttons there is key to certain market segments. But in this case, we just couldn't have it. Just too complicated.
So we said, you know, if the guy who's installing this into the small church or the school is probably an electrician who hung the pipes and installed the dimmers. And he's packing up his tools and loading up his truck, and then he's like, oh, that other line item, I have to train the guys on how to use this. So the idea of this console was zero training. People know how to use an iPad without training, because there's no command line on an iPad. You know, on an iPad, you really wouldn't be, you know, but a Strand 500 desk or even an Obsession or whatever like that, you know, you're staring at, the worst is the grandma. If you've ever seen a grandma setup, you're staring at nothing. There's literally nothing on the screens until you know the special sequence, which is hit this button and this button at the same time, and then there'll be 500 options of what you can put on that screen. And every board operator that runs a grandma has his desk set up completely different than another one, you know. And that's great, because grandmas are on every single big toolbox out there. But those guys who do that run 8 hours a day. They do it 16 hours a day. Sleep for a couple on a shelf on a bus. But the idea of, and this was marquee. This was not Cognito. But our idea was that there will be no command line, because there's no command line on an iPad. So this is another version of the Mimic. And this is interesting. This is probably, this and probably the next video that I'm going to show is what actually tweaked a very big company that owns Pathway Connectivity now, called CITT Brands, to purchase the company that I work for, which is very small, called Horizon. And it was I'll show it later, but there's a video that shows how we were going to put lighting control in something that was this aspect ratio.
The size of an iPhone, basically.
There was an iPhone screen that was going to be built into, it wasn't going to be an iPhone stuck into a desk, it was just that size of screen. And it's like, how can we get everything that you need to do on this little screen? And again, we went with this idea of 4 wheels. This is pretty big in our natural language control deal, about it's always 4.
Just to be clear, that is Cognito. That's the very first version of this desk. So that's from June of 2010. That's what it looked like.
And what that was based on was an iPhone-sized screen, and then during development, we actually found this, which is a really nice capacitive 7-inch touchscreen. So then, I loathe this idea of these things being all over here. But it was like, well, how are you going to associate them with the screen? And this was a huge pet peeve of mine, and I never ever wanted to do it. But see, here's the A control, the B control, and the C control, and they were up there, A, B, and C. And you'll see this on lots of desks where the hardware is laid out around the screen, but they actually have lines that connect them because the hardware is bigger than the screen. And you see this on things like the Hog 500 and the Jans and that. And I just hate that. I can't stand it when I go up to an ATM and there's lines and hit this button and you're hitting the cancel button when you meant to hit OK. That sort of bad user interface drives me nuts.
And what's very interesting about this is this came after those big phone core cockpit design. For some reason, we forgot all about that over the course of a year or two.
Well,
we just didn't do it.
We were being hogtied by the size of the screen.
And the aspect ratio.
So we were very happy when this guy came on our desk, because then we could change it about. Here's another software mimic. This is one Gary did when he first started. So then I did a Google SketchUp model. It looks far, far better than the one that I did that I said was ugly, which was done in AutoCAD a decade earlier. So this was done with free software, SketchUp. And we took this video to Acuity Brands. Van introduced us to Acuity, he was already there. And this was enough, and obviously our pedigree, because we had desks behind us, but this was enough to convince the money guys that these guys might know what they're talking about. So this idea too, we were saying, look, it could be small and in the wall and running a restaurant or something like that, and the exact same technology can be put into a desk and be produced for the church, school, market, and things like that. So, and then it starts to get defined further. So that's when we changed the size of the screen. And then we could happily go back to our cockpit design. Even though it was a very small touchscreen. And the other big, very exciting bit for me is it was a capacitive touchscreen. Because I spent far, far too long on hogs going. So this is great because you never have to recalibrate this thing, and you can swipe on it. And So that changes the user interface a lot. And then there was a huge amount of discussion about, well, what buttons do we need around it, and what's going to be their orientation. So if you look at this one, I didn't even notice this, but this is where those 4 and 4 on the left and the right were originally.
But then you look here too, you can see there's 4 in a slightly different cluster. So we went around the bushes a few times on where to put those 8 buttons.
You might explain to them what you're holding here.
This is actually the first prototype of Cognito. It's called an SLA. It's built by basically a XY printer, just deposits plastic in
3D
layers, 3D printer. And so it just builds it up over the course of a few days.
We actually keep calling that thing an SLA.
It's not really an SLA.
But it's not an SLA. SLA is stereolithography, where you have a big vat of goo and lasers and stuff, point stuff at it, and then they dry the goo out, and then you're left with a model. This is what is now a lot cheaper and more robust is 3D printing. So if I may for just a second, the machine can only do so much. So we cut the desk in 4, and then we just put it together. We never got to putting glue.
Our machine is not that big.
But it actually starts like this, and it's just an inkjet printer with goo in it, and it just starts with, and then it goes up and up. And then when it gets to a hole like this, it actually puts in a different goo. So there's support for this one. So when they start putting the white goo on it again, it hardens up. And then they take the whole thing, put it in a bath, and the goo that's in here just melts away. And then you put it together.
At one time,
Correct term is-
we built the full-scale model console using this and foam. So we had a desk.
Yeah.
Was it big?
The correct term, the correct generic term for this is rapid prototyping. But I mean, literally, you can buy these things for home now and make vases and teacups and stuff like that.
There's a guy here, Stephen Myerson, who's doing his thesis on CNC and 3D printing for props and computer. So if you want to know more about it, go find him. I think his name's James.
Cool. It'd be awesome for props. I mean, like for a vase, you know? It's the perfect thing.
And this technology is a lot better than the SLA process. The SLA tends to be really brittle. The stuff that's cured by infrared lasers. So this stuff, these have been around a while and they didn't fall apart with shipping 10 or 12 times.
When I was working with Philips Very-Light too, and the first time we showed the VLX, the whole thing was an SLA, painted black. You know, when you take it to the train shop floor, and it essentially looks identical again. Now it's actually made of it. And we'll get to that in a second because we're talking about this thing here. This is the model done by Autodesk Inventor. What are the other big cabinets?
SolidWorks.
SolidWorks and stuff. So all the stuff that's in your dashboard of your car and everything. Every product in the world now is done and is completely modeled down to the fraction of a millimeter. And this is done by a real engineer. In this case, his name is Rick King. And so he took my SketchUp drawing and he started drawing it in Inventor. And then he gave it back to me, and then I started laying textures on it and colors. And he's like, okay, well, what if we backlit it in blue? Or what if the
buttons went from oblong to smileys?
What if we did it like semi-transparent? And you could actually see that in Inventor. So we did all of these sort of lifts. And in the meantime, he would start looking at the absolute finest little detail. Like if you look at the slope here, these cuts, this one is quite big like this, but then this one here is sloped down because it actually has to fit this curve because there's 2 circuit boards. One that does the faders and one that does the main board with all the stuff at the back. So, he's looking at tiny little things like that. This guy here, are those the half-moon one? Did we have one that, like around the USB connectors up here, originally he just did a square hole. I said, well, that looks ugly because we have these beautiful smiley buttons. And yeah, that one was square. And the other thing that was pretty exciting for me was that for the first time ever, I got to build a product out of plastic instead of bent metal. Because every other desk I did was just punch metal. But you might get cheeks put on the side of it to sex it up. And they also were always using cherry keys, which is a brand name of the keycaps, or marquots, which are what you see on an Express, or a marquee desk, or a Strand light. And these are just off-the-shelf, the real term is switches, but we call them keys with keycaps. So then at the very best you can pad print your own font or whatever. This time I said, no, I mean, have you ever seen a car come out, besides the Jeep, the original Jeep, that just used a standard headlight? Like every car now, especially taillights is more prevalent, has like a signature design, right? So it doesn't matter whose car it is, the taillight is completely unique and different. And there's a thing about that called sunk cost and commitment to the product. When somebody sees that subliminally, they go, oh, they just didn't get a bunch of parts and bolt them together. These guys actually tooled it and built it. They're committed to the product. And I learned this in university. An economics professor said, would you go to a bank which was like a portable on wheels? Or are you going to go to a bank where there's a big marble statue and big huge doors and stuff? Because if you put that money in the bank where the marble is, you know that it's going to be there tomorrow. They're not just going to pick it up and drive away with your money. So it's a whole subliminal thing where people know these guys are committed to the product because they tooled it. They just didn't bash down and put it together. So they allowed me to design a button. And we built tools for the button. And the knobs. And the encoder handles. So none of this stuff is off the shelf. We got to build tools that did all this. We'll show you a picture of a tool in a
I
minute.
will say that those buttons themselves were one of the biggest challenges over the whole course of the project.
Because they're a light light.
Because they're a custom designed light pipes, and you'll notice that they're painted in both white and black. We went through a ton of iterations of different materials and different coatings to make the letters show up and not get scratched off, and to get enough light through the button without having to destroy the LEDs underneath. So it was a huge challenge.
And to homogenize it because there was 3 LEDs underneath, the red, green, and the blue.
Yeah.
And we wanted to have amber up top. We didn't want to have.
So that light pipe is sort of designed as something that projects the 3 chips onto the back of the letter, the white printed letter, which is actually, it's white, painted with white, it's clear plastic painted with white, with black paint on top, that is then laser etched off to see the letter. So it was quite the process.
But I mean, then there's a whole discussion about fonts, and Dave and I have issues with it. I like the font that's on there.
The religious debate.
And sometimes people are, I mean, we got a comment from somebody saying, that's 7. I don't think we have a 7.
Right here.
You have a 7?
7.
There's a hash, right, across the 7. And they're like, what's that? I'm like, 7 with a hash. And they're like, well, I don't know, it looks like something else. I'm like, okay, the biggest hint is it's between the 6 and the 8. We're trying to go for style here. We just didn't want to use Times Roman, And the other deal is there's no English, apart from A, B, C, D. There's no English on the desk. There's a little picture of a pin, there's a little picture of the on-off icon, there's a light bulb, a paintbrush, some arrows, some shapes, a question mark, pencil. So we haven't successfully penetrated the Spanish market yet, the Portuguese market yet. But when we do, we know we don't have to actually relabel it. We can actually just use software. And software is free.
So absolutely.
There's no cost to software. So
Notice he said that it's not free. He said that all the time.
I just thought he was cheap.
Well,
Not easy.
if you pay for the monkey's bananas.
So, if you go back to this thing, this looks really close, doesn't it? It looks almost exactly like this. But, but then these were my notes after receiving that model from the engineer that day. And this went on for 8 months.
8 months at least, yeah.
Every day I would give him a note like, add the 25, 50%, and 75% hash marks on here. So you can actually see 0, 25, 50, 75, and full. Yeah. And that in itself was interesting because those were proud. They went up. But then when we got to tooling it, the tooling guy says, we can't put enough pressure in there to fill the cavities everywhere. So you can't have them dimple up because they just won't get filled with molten goo that will become hard plastic. So then we had to change them, so now they're divoted in. And the problem is, well, now they'll collect dust. But there's other things like I'm getting really persnickety. It's like make the encoder knobs 10% smaller as they look really crammed in there. And this process just goes on and on and on. So yeah, so if you're looking here, these were too close to the buttons, right here. So we shrank that down. So then we had the problem of the radius. And if you look, the knob is going around somewhere now. You can get your finger in that knob and you can spin around like
the
that.
knob design is completely different than what's in that model. We went through probably 12 different knob designs.
Here, the idea was you stick your finger in it, and as you spin, your finger wants to go on the side, so it captured it in. But then when we made it 10% smaller to fit it in, then there was the problem that you didn't have enough radius. Or it was just too awkward to move it around. So then we had to invert the whole design. So instead of being a female cloverleaf, now it's a male cross. And you get your finger in on the outside. And there was another design limiting factor that we haven't even discussed about this yet, but, and this is a massive thing that talks about, we could have just made the desk bigger. But it was a small desk for a small market, and very specifically, this is 17 inches, which means you put rack ears on it, and it fits in a 19-inch equipment rack. Right? So, you can see that we really struggled with space here, because we had this screen. We could actually get the glass, but we ended up getting stock glass. They would have made new glass for us. It could have shaved a little bit off here, but the decision is we'll just make that 10% smaller and change the clover leaf to a cross.
And again, you can see those 8 buttons are in a completely different place on this model too.
Yeah, so we ended up taking these 4 and we line them up like that. So these are called smileys and frownies. It's the same tool, but it allows us to, well, because in an original design, we were actually going to have bump button below and select buttons above. So they were actually going to couch the slider in here. But, there's sort of design constraint. I'm not an industrial designer, but I sort of have an eye to it. So everything about it, like the radius of this and the radius of the wheel, the radius of the dish below, the handle that goes up and down here, we all use the same number, the same radius. So it just seems to tie everything together. And even, these shapes in here, match very similar to the shapes underneath here. And then we make decisions that some of the buttons are smileys and some of them are frowny. But it's the same tool. We didn't have to tool it twice. And there was a decision, one of my notes was, he did a round power key. Because, I don't know why, my note to him is like, I am quite happy if the power key is a frowny and the other one's a smiley. And, there's a great example. So, yeah, the badge in the middle, that's a smiley and that's a frowny. But I said, if you did a power key like that, then we're either going to have to buy an off-the-shelf button, and it's going to fight with the design of the thing. I said, let's just keep all the buttons the same, except for one will be smiley, one will be frowny. So then became the discussion of the handles on the sliders.
So not only did we do 12 different knobs, but we did 10 different fader handles.
So if you look closely, they're all different. Some have little dishes in them, some, it's like, oh, is that big enough for a finger, or a fat finger, or a skinny finger? Anyways, in all the designs, and this was really late in the game. Like we actually even, I think, we escalated it for sure, but that was sort of what it looked like. Because we were ardent that you have to be able to line up 0%, 50%, and 100%, which is bullshit. You don't. Because your hand's on it, and you're just going to push it up until you're happy with the level. Nobody's actually lining it up. But we thought, we need a hash mark in the middle, and you got to be able to see the thing underneath to line it up. And then, have you ever seen the early Pixar movies? If you look at the outtakes, they show you some of the disastrous things that happen. So like, I remember there's one on Shrek, where Donkey, they got some variable wrong, and his hair puffed out. He looked like a chia pet. It's just like, and they actually show you this in the outtakes, and they're just software goof-ups. Well, that happened to us in this case. I was just entering numbers on the model, and all of a sudden, poof, it went out really wide like that. And my first reaction is, oh my God, that is so ugly, that is so stupid. And then in a conference call, somebody said, you know what, I kind of like number 7. So we ended up on number 4, which is a compromise between 9 and 7. So that's the one that we ended up choosing. So it's kind of like a happy accident. No, like literally it was a slip of the mouse or a finger, and it just sort of changed the idea. So this is the tool thing.
Yes, so we actually did 2 different sets of tools. We did this as a rapid prototype. So these ones, you can tell this one has a bunch of red dots all over it. There are a whole bunch of interesting things that happen when you shoot hot plastic into a mold. This mold was made by a prototype company in the US, and I think it was made out of aluminum. So
Aluminum tool with 2 gates.
aluminum is just not hard enough to kind of withstand all the pressures, so they can't kind of shoot the plastic in hard enough to fill all the gaps. So there's always, and they can't keep the tool as hot as the other one. So you get things called nit lines. So there are a ton of imperfections in all these prototypes that we've been passing around. But we kind of knew that was going to happen because we did this using an aluminum tool, which is faster to make. So we got this, and we used these prototypes for our first show, I think, at a CITT a couple of years ago. But then we went back to the drawing board and made a whole bunch of model changes, little tweaks to how the cheeks fit on and screw holes and things like that, stuff you don't see. And then we sent the files over to a company in China, and they started to machine it in hard steel. And I can't remember how long it took. It was at least a month of
a guy on a milling machine, just shaving off.
They start with this massive block of steel, and they start whittling it away. And there is the final tool for, I think, the top side. That's the top side or the bottom side of this piece. And our operations manager standing next to it in some dirty factory in China, Shanghai, and
it's an environmentally sustainable.
well, it is. It's dirty, and then they're using it's greasy metal, plastic, gas all over the place.
But yeah, when they did it out of steel, they could do things like these red pipes on the side here.
Yeah.
They're not pushing in goo. They're pushing in hot liquid that keeps the tool hot.
And then they push in cold liquid to cool it off quickly after to control shrinkage.
Yeah, but we're talking about incredible pressures here.
Yeah.
And they just, the original one, which was made out of aluminum, just had 2 gates right here, and that's where they injected the goo. And it had to find all of its way right over to this corner and fill it up. So that's why they had to change some of these parts to be male instead of female and stuff like that. But this one, we can pass it around again because now you can look at it with a smoother, keener eye. But these sink marks here, what happens when it cooled off too rapidly or too quickly, or I think there's another big one here, because this part is too thick. So it's kind of like a muffin in the oven. It gets a nice crust on the outside, but the inside is actually not cooked. So, and this was very cool for me because, I don't know how many consoles I've built now. Half a dozen. This is the first time we actually did tooling proper, without buying stuff off the shelf and just bolting it.
And the interesting thing about doing that, bent metal, you can always sort of change the design on the fly. It costs you a little bit of setup fees and everything, but you can always make little tweaks and send it off to the guy, that's only 6 blocks away. But once you get into a hard steel tool, you're done. So you have to get it right the first time, or it is exorbitantly expensive to change it. So I think this one is in the range of $50,000. Just I think maybe a little more.
More than that.
Yeah, okay, so they started at $50,000, and so there's no way we were going to go back and try it a third time after doing the aluminum tool and this one. So we really agonized over.
The interesting thing is you can add material to it. So if I wanted to, for some reason, put a little wart on here, bump it up, they can do that because they can go take the tool and drill it out. So taking material away from the tool adds plastic. Doing the opposite of that is possible if you had some guy who could weld really, really well, and then they shave it down again. But it's just really expensive. And this goes back to my thing about a marble bank and this subliminal thing. I have seen time and time again people walk into a booth at our trade show, and they're walking up, and they look at it, and they go, I like that. They haven't touched it, they have no idea how it operates, they just see it, and they go, that looks sexy, I'll buy that. And it's because it looks different than all the batch metal products that are painted with different colors.
And they know that it's a significant investment in time and money and effort to actually get to that place.
No, they don't.
So then there's the electrical parts, and just like we went through umpteen revisions of fader knobs and buttons and layouts and everything, the same holds true for the electrical schematic. There are certain religious debates about what ports had to go on the back. We decided that we wanted to support MIDI and an RS-232 port and some USB stuff and Ethernet, a couple of DMXs. But there were a lot of other things that we kind of threw back and forth, like adding Wi-Fi to it. Do you want to do that? What's that going to cost? What are the technical challenges? What are the support challenges? And so on and so on and so on. So we kind of went around again, time and time again, trying to figure out how we wanted to or what other bits we wanted to put on the board. And one of the biggest debates was actually labeling the circuit board for serviceability. So you'll notice on this circuit board, compared to some other ones, we've actually got labels of what every button is in English, not like the button caps, but in English on the board, so that in the factory, people can easily see what button's supposed to go where. They can look through the hole and go, oh, that's the release button. I know that that's this icon. Poke it in there.
There's the program he uses to draw this thing is called Altium, and they have to label every single part for the bill of materials. So SW1 is the first switch, and a switch is what you and I would think as a toggle, and I asked him. I said, on the silk screen on this, I'd like you to do label this bump button number 1, and he goes, why? He says that's SW9. And I said, so that one's SW10? He goes, no, that's SW14, because that's the way I laid out the matrix. So if you look really close, you can actually see what they are. I'm making those numbers up now. But I said, no, the guys in the factory, when they're building these beforehand, they have to know how to hit bump button number 9, because that's probably a test on them. So the other thing is about how much space is there in a 17-inch rack now? So this is the RS-232 port, which is still used for show control purposes and stuff. That's why we put it on there. But there's 9 pins, and only 3 of them are used for serial communications. So we grabbed some of the other pins, and there are contact closure port. So we can customize that.
But it was also interesting to, just the direction that the XLR ports face. We weren't sure that people would accept them facing downwards. But once we built the console and built it with the overhang, we realized that there was no way to get your thumb in there to actually unplug the XLR connector, so we had to flip them over. We didn't really have a choice in the end. Either we changed the entire model to bring them down a little bit, or we just flipped them over. So there are the things that you kind of end up discovering as you build it.
So from the schematic, you saw, which is actually, you saw a tiny portion of the main pieces there are. Then it goes to a thing called circuit board layout, which is where you get the buses and the traces. And that can be done sort of automated, but it's quite a science to, well, first off, the mechanical engineer says, well, this is the hole for the number 11 bump button. So these are where you need to put it. And that's exactly this many millimeters from the number 12. So then they lay those things out, and they're like, okay, where can we put a processor? Well, there's space between the 10 and 11, so we'll drop a processor down there. And we need to put these connectors here and all the rest. Then they have to put it all together with the bus lines. And you probably know that there's more than one layer, because you need to. So then when you need to get a bus from one layer to another layer, you have a thing called a via, which will actually take it from one layer down through another layer. It actually is drilled all the way through all the layers, and then they just put copper that will pick it up from one layer and take it to another layer. And this process itself can take
A week, depending on the complexity.
4 weeks.
4, yeah.
Then from circuit board layout, it turns into circuit boards. And I meant to take a picture of the pick and place machine yesterday working at the factory, and then I got a phone call and I forgot, so sorry. But this is really cool, because it's like an old pen plotter. We have a machine in the factory that has these reels of all the components. Like every part, well, not every part, because they do it in stages, but they load up the machine with how many parts? How many reels can go on your machine?
Maximum 192 reels.
That's a lot. Anyways, then this machine goes over and picks something off the machine, and then
There's a suction nozzle, a little head on it, and it rotates it.
Then they take that whole thing and bake it in an oven, and the solder melts and everything sticks to it. So that's called SMT, surface mount technology. And this is the factory. The machine is just to the left here, just out of view. Here's Ron. He keeps everybody in control back there. And then this is the burn-in racks, and these are part bins. So the guys, the parts wouldn't be resistors, the parts would be a handle, a knob, a fader. And these are the burn-in racks where after we build the desk, they burn in for about a week. And they reboot it a couple times and they just make sure that it's healthy before they package it up and send it off. Then we would send the whole thing out for EMC testing, which is electromechanical. What?
Electromagnetic
electromagnetic compliance.
compliance.
Lines, yeah. And this is big for going to Europe, especially. And we get away with a couple things. We don't get away with much, but one of the things we didn't do is we didn't have an IEC cable right on the back of the desk that had the power supply in it. It was a brick that does power. Oh, and that's another interesting thing about this product. You all know what power over Ethernet is, right? So you have an Ethernet switch that will power up your path board nodes and stuff like that. You can take one wire to this desk and it will power itself up over Ethernet, touch screen, little lights, everything, and then send the data back out. So you can just have one wire that takes this thing.
Kind of like the old NSI desk, you know, with 8 faders, and you plug it in with your 3-pin XLR. We do that with Ethernet now.
So EMC testing is a real trick, but having the power supply out of the box is a huge help. And then this is Gary's deal.
Yeah, so there were a lot of options when we started, sort of software-wise. So we've gone through most of the mechanical stuff, and you can see that there's quite a number of iterations you go through, starting with that, you know, the model of the console with the encoders on the right, and then moving things around and sort of tweaking it until Robert's happy with it, until the customers that we showed it to earlier were happy with it. And then there's this big nebulous world of software. How are we going to make Robert's vision for natural control and the mythical vision of having no manual, and how are we going to integrate all that together so that we actually sort of meet our goals? And we started off with that, and you saw that early model from 2010, and it had a very sort of iPhone-like interface. Our goal was to be kind of as close to the iPhone as we could, and for a lot of months, I want to say 8 to 10 months, we really did push on that concept until it ended up that we were butting our heads into it just far too much. It was getting in the way of us being able to control lights. So we wanted to have some fancy animations and some sort of eye candy. But we realized in the end, eye candy didn't turn the lights on or turn them red or make them go downstage left. So we sort of abandoned that for, I want to say, a seamless interface. And in order to do that, we had to sort of change technologies on the fly. We used what's called a toolkit. There are a number of different ways you can paint a button on the screen. We chose a certain way of doing it, and ended up midway having to actually throw most of that away and start again, just because we couldn't do some of the things we wanted to do. So it's always an iterative process as the software matures and as we kind of add more features and graft more things onto it. You end up painting yourselves into corners and having to back out and do it again.
One of the things that, you know, it'd be nice if everything flew in and went across the screen animated like.
Yeah.
But it's expensive. We call it expensive on the processor. It takes too much. And if you're not producing DMX at 40 times a second, then your stage doesn't work.
Yeah.
So, and the reason we never really fought with this before is because we were doing it on big i7s or big processors. This is running on a little R9, which is powered over Ethernet, which doesn't have a fan. Those were design constraints from the beginning. No fan. Has to be powered over Ethernet. So it's not a big i7 processor with a massive heatsink on it. It's a little tiny, little tiny processor. So Gary has to tweak out every single possible cycle out of that.
You have to produce DMX coming out
two streams of DMX
at 40 updates a second, and make sure that when you're fading from red to green, it doesn't do it in big, huge chunks. So you have to make sure always to sacrifice eye candy for the performance of the desk. Yeah. So this is our bug list from, I don't even know what date that is, August 13th. So this is our feature enhancements and tracking list, and there's always, I want to say, 100 things that we'd like to change in the software. And that's always been, I've been working in this and other code bases for 15 years, and there's always 100 more things you'd like to do. And as soon as I fix one, he finds something else, or some customer comes up and needs a feature desperately to do some whiz-bang thing, XYZ. So it's always a process of improvement, continuous improvement, just one step at a time. Each of these represents a step. And then there was the graphic design, icons, things like that.
I am not an artist, but I drew all these little things. So when you look at the screen and you see a parkan or a joystick or whatever, all that stuff has to be done and shaded nicely and drop shadows or whatever. So that's a whole other process.
And interestingly, we actually had a graphic designer who had very little theatrical background, and we asked for certain icons for certain things. I think, well, what's RemDim? Where's an icon for RemDim? And how do you explain what RemDim does to somebody who's just an industrial designer fresh out of school? It's a pretty tough call. So always things like that end up falling on Robert or myself to say, oh, well, we're the light guys, we can come up with something.
Remember all of his initial work when he was showing it, he used out of the Venner model. So all the work product he sent out the console was upside down because that's the way it was.
And then there's a whole other software product that we have with the iOS, an app called Cognito, and it's our job to make sure that looks a lot like the console, and if the console changes, obviously that changes, and if this changes, the console has to change to match it, along with the sort of back-end communications between the two. So that's always, we're kind of trying to be lockstep, developing that as well. So there's keeping those two code bases in sync is obviously a challenge. And support. Everything we do has to be backed in with people who can answer the phone if a customer has a problem. And you always have to think about, everything on the desk, from software to the buttons to everything. Everything we put in here has to be. You have to be able to support it without, spending too much money or taking too much of support's time.
Well, and answering to the customer, because as I always say, at 8 o'clock Sunday night, there will be a show. Lights are on, right? So if they call you at 7:30, you got to be there between 7:30 and 8 o'clock solving these problems.
And I think our industry is quite unique from a support perspective, where all of us get calls at generally 5:30 on a Friday evening when something bad has happened and they just don't know where to turn. So generally they just start making the rounds of all the business cards they have, and eventually they find us.
And that's it.
And that's the end of it. That's what it became.
So, I believe coffee is sponsored by Pathway Connectivity. Is that right, Robert?
Yes, it is.
Where is coffee? Next door?
That I don't know.
So, we're going to have coffee, and it would be really nice to see some of you guys back here, and I'm going to talk on a very different subject about controlling color with LEDs, and why it's not as easy as just changing the chili. Thanks.